So welcome to the Dawn of the Data Age webinar, Creating a Data Culture at Your Organization. My name is Luciano Pesci. I have two roles that I'm going to bring to bear on this question today. The first is as founder and director of the Utah Community Research Group at the University of Utah, where I teach microeconomics, statistics, applied research and data analytics, and American economic history. I also teach data science for Westminster and developed their 3-class MBA emphasis in data science. But most of what I'm going to be talking about today is not really from my academic background or the teaching. Some of the methods are things I teach my students. Most of what I'm going to be talking about today is what I've observed as the CEO of Emperitas. We're a services as a subscription team of economists and data scientists delivering bi-weekly customer lifetime value intelligence. So this means that we're data scientists who help people who usually don't have a data science team already, or if they do, they've got one person on staff. We really help those organizations move into the data age, hence the title of this webinar, by working in quick sprints. And we'll go over what we've learned as an organization about our own data culture internally, but also the data cultures that we've observed out in the private sector. So here's the outline for the webinar today. I should stay under an hour. Again, if you have questions, please just ask them into the chat. The first is to teach you how we got to the current state of data. This is a new problem. I want to then explain the 4 different types of data scientists and their tools. I want to outline the successful data science teams and its costs, and then show you at the end how you can start to create a successful data culture at your organization, which is a lead into the next webinar, getting to quick wins with data. So in economics, there is something called the counterfactual. It's what happened if instead something else happened. So you go back and you look historically and you say, what would the economic impact have been on the US economy if typing had never developed? If no one had ever invented this technology, it hadn't become widespread and adopted, what would that do to modern economic situations? And so if you stop for a moment to think about that, in your own organization, everyone is now a typist. It used to be a job that one person had, and now everyone does it. Data is that 100 times over. And so not having it among your entire team is extremely uncompetitive. Let me mute that fast. So not having necessary skills like data across your whole organization is sort of like if you had one typist instead of one data scientist. How would that slow down your organization? You know, the initial motivation for this webinar series, and to explain, this is a webinar of a lecture that was actually given last week, and that's what's happening in this series. There are live lectures. If you're in Utah and you want to come by, they're free. We'd love to have you. But for those who can't come or aren't able to make it when it's happening, we wanted to repeat this in a digital format so other people could learn this. And I started off the live lecture by saying that the motivation for this whole series, why I decided to start to do this, is because I do have contact with so many former students who I have trained in data science, and they go off into the job market and they're very excited. They've got incredible skills. They usually find really great jobs. They get there and nothing happens with them. They're either not given the freedom to do the work, or they're not given any direction. Nobody knows how to integrate with them. And after about 6 months, they get very bored and they move on to another organization. And so I've watched these former students, bloom into really great data scientists, but that path has been one of multiple repeated failed jobs where they didn't feel rewarded or utilized, followed by one really great one. And as I stepped back and tried to understand why this is happening at the same time that most data projects are failing, something we'll get into, what I realized is there's really a bad disconnect on the organizational side about how to use this data talent. And I don't fault organizations for not knowing how to do that. This is a new problem, because data used to be the domain only of the government. It was just so expensive and so hard to do this work, all of which was done by hand, no computers, no typing. Only the wealthiest, most powerful organization, which historically till the last few hundred years has been the monarchy, it was their prerogative. All things would come into the state to be measured, weighed, sometimes then dispersed. And so the word statistic comes from this council of the state, the people who are counseling the king on what to do. Well, that's changed. And what changed it really was some momentum that got a tipping point happened in 1956. So this is the year a transatlantic cable capable of 36 simultaneous transmissions was laid and became operational. 6 were for government use only, so really the private sector had 30 lines of communication now. That's the birth, though, of what will eventually become the internet, which is allowing massive amounts of data to be sent, stored, and captured. The second thing that happened in the same year is that IBM started selling its first commercially available machine, the RAMAC. You had 5 megabytes of data for $30,000 a month in today's prices. And it's just an accounting machine. Commerce was getting to the point where even private organizations now needed real-time intelligence from an accounting standpoint. They needed to be able to pull a customer file and look at what was happening. And they could do that for $30,000 a month for 5 megabytes. So that computing technology, that international connectivity was then spurred again by the government. This is a government organization, DARPA, that laid this, what became the backbone of the internet. One of the first nodes is here in Utah at the University of Utah. It was originally called the Intergalactic Computer Network. This was meant to be something, and look at the order. This is a quote straight from them. This is the order of priority. It is for governments, institutions, corporations, and individuals. While that may have been the early vision, that's been flipped. Individuals are absolutely driving the internet and all of its technology today, and to a lesser extent businesses, to an even lesser extent government and institutions, meaning higher education. From that moment, one human lifetime later, we have a completely changed and different world. And if you look at just the growth in data itself in the last 2 years, 90% of all data that exists wasn't there 2 years ago. And it's just accelerating. So here's the momentum. In 1992, you had about 100 gigabytes a day being created. 2018, 50,000 gigabytes a second are being created. And it's just going to get bigger and bigger and bigger and bigger. The price of all the technology that's necessary to do data science has collapsed. And you can see it in processing, so gigaflops cost per gigaflop. You can see it in storage, cost per terabyte. You can see it in the broader connectivity that we've been talking about. These are almost 100% price collapses, and again, in one human lifetime. There was a great image going around. You could probably find it if you Google it. What would have happened to cars if they had kept pace with this kind of technological speed? If basically car technological progress matched computing technological progress. And the cars would have 660 million horsepower today. They would get 3 million miles per gallon, and they'd cost about $4,500. So if you just take that same mentality of what has happened in computing and you apply it to the 100 years of automotive, and you can just see the scope of the difference, you can start to understand why this is a new hard problem for organizations to tackle. And it's not something that's going to go away. In fact, it's just going to keep growing and growing and growing. By 2050, the global population is supposed to peak around 10 billion people. The number of connections per individual has been exploding. The pace at which those connections can be in real time, sometimes captured, is exploding. And it's causing some issues. There's definitely been some problems with big data, and companies have had a lot of failure that I'm going to get into trying to move into this world. But the benefit of it far outweighs any of the costs, because we're now able to quantify things that just previously were unquantifiable. And if you go back a few hundred years to when The statistics were the domain of the state. They are measuring main outputs. They're measuring tonnage. They're measuring qubits. They're measuring these very large key performance indicators. And now an organization can have the most minute key performance indicators, and they can have it in real time. So why is everybody failing? You would think that with all this great information, in fact, economic modeling would say that with more information, you get better outcomes. Yet 80%, 4 out of 5 data projects are failing right now. I believe it's because these organizations lack a data culture. And I'll explain what that means. But it is a broad literacy. It is an environment that rewards data, that doesn't punish people for showing data that might not be preferential to what other people's beliefs are about what's going on. But the data culture is only one part. The other is that even if they have the desire to work with the data, a lot of it's living in departmental silos. So you've got data in marketing that would be useful to sales, and they don't share it. And then you've got data in finance that would be useful to sales and to marketing, and they don't share it. And so these data silos are horrible. The worst silo for sure, though, is the executive team. They are not sharing with the data teams what they need. There's too many intermediaries there. But everybody also has a different baseline about what data is, and then there's a lot of disagreement about how to use it. This, I believe, stems from the fact that statistics is the worst taught subject in higher education currently. This is changing. There are a lot of programs that are adopting engaged learning or applied learning, but most people were trained in statistics in a way that was, here's an equation that you don't understand the math behind, and at some point you can just plug a couple things into it. And that is not a skill that's translating into good outcomes with data right now. When John Chambers left his role as CEO of Cisco and moved into his executive chairmanship, at the company's event, he announced this to the room full of what are basically his customers. He said that 40% of businesses will not exist in a meaningful way in 10 years. And this is because, he says, the world is digitizing and people are not keeping up. But another key metric here to look at as a predictor of the future disruption to come from data is that Fortune 500 companies' life expectancy is down 80% from 1955. And you're seeing this all the time. The story, I think, till recently has been you get a new startup. That startup's more agile and nimble. They can respond better to the customer. They understand the customer better because they're using data. And somehow they take down these old established businesses. And that's definitely been a part of the story. I think if you've been watching what's happened with Blue Apron recently and Amazon, it looks like that story can go the other way too, which is that these big organizations, if they start to adopt some of these same methods that startups are using, are capable of then crushing those startups. So here we are again, the 1 in 5 that's going to survive will be the one that's using its data the most successfully. And there are really good success stories. The majority of people are failing, but those who are succeeding are doing a remarkable job. Amazon is the undisputed leader, in my opinion, when it comes to using data, with Google being a close second. But Amazon's been using their customer data to remove friction from every single part of the buying process. That's how they eventually learned and then went and patented one-click buying. And now you've got the dash buttons that they give you. Now there is one that you can just scan something or take a picture of it and then press the button and it will order. They're just making all of the pain points go away for their customers by watching that process and then using the data to do targeted upsells through their recommender engines, by bringing in a community sense through public reviews and analytics that can help people vet a provider or a vendor. And the result has been they really are just destroying traditional retail. Tesla is another recent success story. This shouldn't be surprising. Elon Musk is part of the PayPal mafia, so this is the group that was involved with PayPal in San Francisco early on, and a lot of their former members have gone on to found new unicorns, Tesla being one, LinkedIn being the next that we'll talk about. But Elon Musk is using data from the car for many reasons. One is to improve the product, the other is to improve the customer experience. Another is to just capture the data of driving and use it to train artificial intelligence. And so they just announced, and you can go to their page and see this, they're now taking all the video feeds from these vehicles and they're using all of it. And then LinkedIn, who, following this acquisition by Microsoft, really showed the potential power of professional social media. And it's one thing to get everybody into one place to network, but if you're smart, you start capturing all that data between them. And LinkedIn is very smart because Reid Hoffman is also one of the former PayPal mafia. And they use these insights to figure out how to rank individuals and then how to job match them. And I think the real promise of what can happen here with LinkedIn is that if they're successful in using this data, they will kill traditional hiring as a practice. Why would you go through the whole process of traditional HR onboarding when you could just instantaneously be matched to someone that you have 99% confidence is going to work out, and they just immediately jump in and start working? And so that efficiency gain will destroy the traditional job application market. Okay, those are the rare successes. The majority are failing, and I think it's not because of a lack of ability. I think it's because they don't try. There are many organizations who think that they can just continue to do business as usual, and they are finding out. I think Stripe proved this with the payments industry. They are proving to be very, very destructive on markets that do not adapt quickly. And so, like anything else, data, for those who embrace it now, is not only going to help ensure their survival, but right now, while other people are burying their heads, it actually is a competitive advantage. Now, that's not going to last. It's going to be like typing. Every person in the organization will have to eventually be capable of doing basic data work, understanding data, data interpretation. You're going to see just data undergrad degrees popping up around the nation, and it will just become a commodity like anything else. But for right now, it is definitely a competitive advantage. So how could you jump in if you don't have a data culture right now, or you're thinking of building one, or you've started to build one and you're not seeing a lot of success? I think a big part of this comes back to organizations don't know why they're hiring this talent, which also means they don't understand how they're going to use that talent, which also means that the chances of success in those situations are very, very low. And if you as leaders or people who manage other teams can start to understand just the basic core functions of data science, then you will be able to get very good at hiring the right kind of talent for the right job. Those people will feel rewarded. They won't leave after 6 months, and then you will start to turn into one of the 5 success stories. So here are the 4 types of modern data scientists. Okay? And I'll get into their actual. I use a different labeling than this. This is an infographic. I did not create this. This has been floating around on the web for quite a while now. But it captures the core skill sets that are being asked of data scientists right now. They need to know math and statistics. They need to be programmers and to be able to use databases. They need to have domain knowledge and soft skills, meaning they have to understand business. They have to understand your business. And then they have to be able to communicate and visualize. And this is an incredibly rare combination of skills for any one person to have, so much so that they call them unicorns because they don't exist. Data science is a team effort. You can't hire a single individual to do this. The skill set of databasing has some overlap with programming, but it is not the same skill set. And those are deep enough specializations that if you get someone who just has a very shallow understanding of each, you're not going to get very far. This is a team effort. It requires cooperation. It requires specialization. And I believe this is one of the biggest things driving the failure right now. So I said I use 4 personas to outline those different roles as far as how you could divide these jobs up and think about hiring people. These are the four, and they come in different combinations for different tasks. That's something I'll get into shortly, but it'd be good for you to really understand these four different types of data scientists. There are data detectives. These are analysts and researchers, people who might be capable through market research of generating primary data. They understand data, they understand a little bit of analytics, but their real specialty is that they're the ones with the domain knowledge. They're the CIA type analysts. They know everything there is to know about X, whether that's e-commerce, whether that is digital marketing, whether that is whatever your core function of your offering is, your value proposition. They know everything there is to know about that, and then they have some data literacy that will allow them to interact with these other three roles. The next are data guardians. These are database administrators and ETLs. So ETL stands for extract, transform, and load. These are individuals who have a little bit more programmatic skill sets than the DBAs. The DBAs are people who are going to build the infrastructure, build the actual database, maintain it, watch users, protect it from threats, understand what data is going where, but they're not programmers like the ETLs are. The ETLs are people who are going to take that data out of a database environment, probably put it in some other lake where you're going to do all of your analysis on it, a data lake, and their job sort of ends once the data is there. And that they hand off then to the next group of data scientists, which are data wranglers. And these are the people who 90% of the time, when someone says they're a data scientist, this is what they do. They're statisticians or programmers. Almost all of them come from a computer science background. Very few of them come from other fields, so economics, like in my case, or other social sciences, psychology, sociology, or maybe hard sciences like astronomy or physics, or sometimes from engineering, not computer engineering, but actual mechanical engineering. The point is they are individuals who usually have a PhD in their field, and as a part of their study, they learned data analytics because it's being used in their profession. And there's been a lot of crossover, successful crossover, of pulling these people from other fields who have heavy data skills into this role as a data scientist with a private organization. And then there are the least frequent yet most needed data science types. These are the good communicators. And I do not mean to fall into the trap of dismissing the data guardians and data wranglers as recluses, but they are not typically good visualizers or storytellers. They don't usually communicate very well. They are very good at their tasks, but their task it does not involve or require translating that information into really simple terms that hit with the domain need and the business need, and then doing it in a engaging way that actually sticks with people. You know, at Emperitas, all of our programmers sit in a dark room with the lights out, the windows are blocked up, and they got headphones on. They're not great communicators. And I think that this is partly why if you try to hire one person to do all of these skills, you're setting them up for failure. But the data storytellers are the ones that are most needed right now. So let's go briefly into detail on each, and then I'll go into the team structures and costs that you'd expect for each of these, and then we'll end with how to move into a data culture. Like I said, these data detectives, they are primary researchers. They know everything there is about your space, your market, your competitors, the regulation affecting you. They know maybe even the hierarchy of people in regulatory agencies or in some sort of association body. They know everything about your business, and they've got a pretty good understanding of data. They might even be able to collect some. Market researchers tend to fit this role really well, because even if they don't know your business, they are capable of learning it very quickly, and they know the best methods to do that. Things like traditional surveys, qualitative interviews, trend reports. They will go out and learn everything there is about your space, and then they'll be able to identify what kind of data is worth getting. The data guardians are the people who are going to centralize all this information. They will build the physical infrastructure and possibly the software infrastructure to support this. What was traditionally 3 or 4 jobs have now all merged into one job for database admins. So it used to be that you would be an architect, and that's all you did was design the whole database system. And that job has been absorbed along with the IT function of setting up servers. And then, okay, you set up the physical infrastructure and then you get the software running on it, and you build out the database. Why don't you just be in charge of knowing what everything is? And so the role of stewardship, that again used to be an independent position, has been absorbed. And at this point, DBAs, I think, are the most overworked, underappreciated of all these data scientists, because they get lots of really, really crazy requests for things that are not possible. That's part of IT. But without them, you don't know if what's in a table is consistent or not. That data stewardship part is very important because, as you'll see in future lectures and webinars, data context is the most important thing to understand before you start digging into any analysis. And if you can't answer what is this because there's no data steward, it doesn't matter what you have, you're not going to be able to use it. Their tools are mostly SQL based. There's some non-relational, especially if you're doing a lot of large e-commerce. They prefer, or social media, they are preferring non-relational databases, but most are still SQL-like. So if you're looking for skill sets to identify these people, just like in the last role with the data detective, someone who knows Qualtrics or knows market research, with data guardians, if they understand SQL really well, that's an indication that they could fit this role. Now, the physical infrastructure component that's been tied to IT, that seems to be going away as things move to the cloud. And so maybe they'll get a little bit of work taken off their plates. The third, and I said this is by far the majority of people who call themselves data scientists, are programmers. They know how to pull data from APIs and databases. They might know how to program something that scrapes the web of public information. They can run advanced analytical models. But they're programmers. Their skill set, they'll call it their stack, are things like Linux, Apache servers, C#, C++, Python, R, Spark, PHP. These are all programmatic languages, and they all differ. Their core skill is still the same, and so you will usually see that someone who has learned how to program in one language knows how to program often in multiple languages. But the stats savvy ones are meaning that most of the work that they would do is statistical in nature, not just programming. You'll see them, they will put R, Python, Spark, and Hadoop on their resumes. These are by far the more expensive data scientists, and so if you hire them to build your database, that's a mistake. If you hire them to go figure out what data should be out there, again, that's a mistake. Their skill is that if data exists or you want data from a specific source, they can write the program, in some cases software too, to do that. They're not very good, though, usually, at storytelling with their output. And I said that this is the most needed of all the roles. I'll reiterate that again, because you can go through all that work of finding the right data set with a data detective, putting it in the right place in an appropriate table structure with the data guardian. You could have the world-class data wranglers. There are some of these data wranglers who are coming out of these Ivy League schools right now, and they're getting huge signing bonuses. They have agents who negotiate their pay terms. They're being treated like star athletes, right? And they could be the absolute best at what they do, and they could process all that information. And then if decision makers don't understand what has been done and what it means and what to do with it, they're not going to make a decision based on it, and it will have all been for nothing. And so this role of data storyteller, this is where all that work gets turned into a very easy to understand, visually rich mix of presentation with slides, with other supporting material. They translate everything that's been done into easy to understand terms for decision makers so that action can then be taken on that data. Because that's the best way to validate if the data was correct, is repetition. And so if you keep delivering things that decision makers are hesitant about and they don't make a decision on it, You never actually get the chance to find out if your model was correct or not. There's no guarantee models are going to be correct. I'll get into that in a moment. But the skills that these individuals bring, they're good with visualization tools like Tableau, Power BI. They know how to make PowerPoints. They know how to give presentations in front of large groups of people. They're good at fielding questions. It's a very rare skill set, and one that if you can find an individual to fill this role, this is an important hire. So what are the costs of these teams? I mean, everybody knows that data science is expensive. So let's give it a couple caveats before I go into the hard numbers here. There's an inflection point in revenue around $10 million. So if you are an organization that is doing less than $10 million in revenue, you have to approach this very differently than an organization that is making more than $10 million. The right data science team, I'm going to show one for under 10 million, one for over 10 million, but the right data science team depends on a couple pretty important distinctions. So first is the technical nature of your product. If you are an app versus a services, that's going to be very different. You're going to have very different kinds of data to deal with. Where you're at in your product life cycle. So if you're in your rapid growth phase versus your maturity phase versus your death phase, that changes the kind of data that you really need to be working with, and that can slightly change the team that you have to utilize. B2B versus B2C is a very important distinction. The only caveat there is that if your B2B has tens of thousands or hundreds of thousands or millions of customers, then your data needs kind of fit what happens with B2C, because the difference there with B2B and B2C is usually the number of customers, and that affects the type of data that you have. You're not going to have big data necessarily if you only have 10, 20, 30 customers. Another is the state of competition in your market. This really affects how quickly you need information and how quickly you have to be able to act on it. If you're in a market that changes very slowly, then you have potentially the time to do deep, thoughtful, well-planned out work. If instead you're like 99% of the environments out there and you're in fierce competition, then time is really valuable. And you need to build a team that can do things in agile sprints, which we'll get to in a bit. And then revenue, I already said, is a very important distinction. In all cases, what I'm going to present to you, I implore you, don't put a thick layer of middle management between you and this data team to start. There has to be someone at the top who buys into this. That person needs to have some technical savviness. They don't need to be a data scientist themselves, although Chief Data Scientist, CDS, is one of those. Chief Analytics Officer or Chief Algorithm Officer is another that's common out there. CTI, CIO, everybody should know those, but CDO, Chief Data Officer, these individuals should have direct interaction with this team. There can be one leader in between them, but if you put whole systems in place where you only ever get their output, this is not going to work to get started. Okay, so if you're under 10 million in revenue and you have a lot of well-organized and accessible data, so let me define what that means. Well-organized and accessible could be Excel sheets. It could be. It could be Google Sheets that you've been keeping on Google Drive or on Box. Or if they're well-organized, it means that the structure of those data files doesn't change from file to file to file very much. So maybe you're just using the same template every month and you're just filling it in. That's well-organized data, even if it's not in a database. Ideally, it should be in a database. But most organizations who are under 10 million in revenue, it means that they've either hit a market cap and they're going to kind of coast along at whatever they're at, or they're in that growth phase. And usually when they're in that growth phase, or if they've only gotten to 5 or 7 million and they're hitting their market cap, that's often a sign that their internal structures aren't optimized as best as they could be, and that's probably because the data isn't well organized and it isn't actually accessible. It's just in spreadsheets on different machines, different places. Some people who don't work there anymore have access to it. That's not well organized, accessible data. So I don't want you to feel bad if it's just in Excel sheets. It's just the test that I give everybody that we work with is Could you find it for me in 30 seconds? If I asked you, oh, I want to know where this data came from, could you go show me at least where that came from in 30 seconds? And by show, I mean not just like point me, oh, it's in my computer. I'm saying, okay, show me the file. If you can't, then it's not organized and accessible. But assuming you do have well-organized and accessible data, the first hire you should consider is a data wrangler, someone who has that deep programmatic skill, understands statistics, can do a lot of the things you'd want, not going to be the best storyteller, probably isn't going to be very proactive in what kinds of data to get. They're going to require your direction on that. But they can also usually deal at a small level with databases, at least pulling from them. And then the second hire would be a data storyteller. Now, if you don't have a lot of data, you should start with a data guardian. That person should be charged with archetyping the system, building out the hardware, getting all the users set up, testing for security, and then getting protocols in place so that all the data starts to get well organized and accessible. Once that has happened, I would skip over the data wrangler and go straight to a data storyteller. You can usually tap Tableau right into existing systems. So you might have Salesforce, you can integrate to it. You can integrate Tableau straight to Qualtrics. The danger there is the data is not cleaned. But for starting out, that data storyteller can get some big ideas about what's going on, and then you can hire a data wrangler who will come in and clean it up and do it at a more refined level. So these are national averages that were done by primary research methods to get to these values. The values after each of their titles is the expected salaries. The total annual costs include not just those salaries, but also tools, training, and overhead. I encourage you to only look for candidates who know about and utilize open source tools. Not everything they will need will be open source. You will inevitably end up having to pay for some of the tools they need. But some of them are open source, and that saves you a lot of money, potentially. And there's no reason not to be utilizing them. They're very good. They're very stable. Training is one that people really overlook. This is a constantly moving field. It is in flux right now. You cannot hire someone and have them just go to work for the next 3 years with the same methods that they had, or you're going to find that they're not very good very quickly. And then traditional overhead markup brings this total cost for a $10 million in revenue company to $403,000, which is, if you look at the efficiency ratio, so if you look at the cost of some department relative to revenue, this is on par with IT. It's more than accounting, but it's far less than sales and marketing. And the difference with this team than any of those other teams is that their skill set can help every one of those departments in the organization. This team should be helping the finance department. This team should be helping the sales and marketing team. This team should be helping the decision makers with long-term strategy planning. They need to be across the battering ram that knocks down all these silos within the organization. And so while their efficiency ratio comparatively is not terribly high, the value that they bring, the ROI that they will bring to the organization is huge. And I have these lunches occasionally. Students will reach out to me and I'll take them to lunch. And I have one student in particular who works for an e-commerce company. And I call them $1 million lunches because every time we meet for lunch, he tells me some story about how he used some very basic analytics at his organization and he saved them $500,000 here, $500,000 there, $1 million here, $1 million there. This is just one individual on that team. So they benefit the entire organization. Well, what about organizations that are over 10 million? Obviously, that is a giant grouping. So what I recommend is not that you think about building one big team that continually scales up and up and up and up, but that instead you think about this as small groups of 5 people that can just be replicated. And then, this does not take into consideration additional management that will have to be put in place once you have, 3, 4, 5 of these teams. But the core of these teams and their costs are laid out here. So should you have more than 10 million in revenue, one data detective, one data guardian, two data wranglers, and one data storyteller. A team of 5 people with those skills will do incredible things for your organization with data. And once they've hit capacity, and they will hit capacity, you need to just build a second team like that and put a director over those 2 teams. And a director should be able to manage 5 of these teams. And these teams should each be able to handle, I'd say, 2 to 3 projects simultaneously. So the total cost, again, of all their tools, training, and overhead, not including that additional leadership you may or may not need to hire, is just over $666,000. We did primary research to figure out those costs, those prices, the tools, the training that these data science teams need. The feedback that we got directly from these data scientists as we spoke to them, these are active data scientists who we surveyed and had conversations with. A common theme was size. Don't let the teams get too big. And one quote from one data scientist stood out. He said that if you can't feed the whole team with 2 pizzas, the team is too big. And so think about this as an easy KPI to be thinking about. If your data science team is starting to get to where it cannot be fed with 2 pizzas, that team is too big. It's time to replicate the team. Each team would have to get 2 pizzas. But the reason for this grouping of 5 is it's rooted in a lot of other theory. One is that it's around 5 that you start to get really predictable patterns. So you can see this in agriculture. You put 5 people in a field, then you start to get predictable output. It's been proven with experts. You get 5 experts who are capable of working together, and they will outperform any other single expert out there and do it in very consistent and measurable ways. And so really think about keeping that, it's 5 people can be fed by 2 pizzas. So let's say you get ready, you put all the job descriptions together, you go out, you go through the traditional hiring because LinkedIn's algorithm isn't quite there yet and hasn't brought you the perfect candidate. And you go through the traditional hiring process and you end up with one of these teams. Your work is not done. You have a lot to actually do because this is a top-down problem to build a data culture, and just hiring the people without any sort of direction will not succeed. So let me define what I think a well-functioning data culture is. Okay, it is something that combines people and software. And I say that because I have seen analytics companies that are run on the human replication process. So you get another client, you hire another person, that person does a crosstab. That's their job. It's basically factory production with analytics. And that is not scalable relative to a machine. It is so much easier to program a machine to do crosstabs and have one person who knows how to program a machine to run thousands and thousands of crosstabs instead of just hiring another person to run another crosstab on another data point. So that best of human and machine, I think, really could be better described just by the word automation. I mean, the humans and the computers working together around the goal of automation, because that gets the next, which is fast and agile methods. Data gets stale quickly. It's not useful after a very long period of time. And so if you're not on an agile approach, meaning you're getting updates at least and holding people accountable in 2 to 4 week sprints, I think the 1 week sprint is a little too fast. We've tried the 1 week, we've tried the 2 week, we've tried the 4 week. We think the 4 week is too slow and the 1 week is too fast. The 2 week is just right. And that means that every 2 weeks, everybody knows what needs to be accomplished in the next 2 weeks. Everybody knows who will individually contribute for that sprint, what they will do during that sprint, what their measurable outcomes will be at the end of that sprint, and when everything is due. And this has proven a very effective way of doing data science because, like the dashboard mentality that has destroyed a lot of belief, I think, in analytics is this idea that you can just look at it once and run it on cruise control and that's it and it's just fine. And that's not the case. As soon as you see something, every decision maker that I've ever seen with dashboards, there's no deep understanding. They look at it and they say, great, but what's causing that? And the dashboard can't answer that because it's a static visual. And so this is again why 2-week sprints get you to deeper understanding faster, because you see something and then you can go investigate it further. It also allows you to pivot, which keeps you from going down a bad path for months and months and months. Deep understanding means that the individuals involved all have a descriptive level understanding of the processes and the outcomes and what the results, conclusions basically, and recommendations were of the project. I think part of why data science is failing is because, like I said, there aren't that many successful data storytellers. And so you do have the best people and machines who are working agile, and they produce this really great analytics work. And then, the decision maker just doesn't understand it. And so then nothing happens with it. The fourth component is it should be tied to strategy. There's stuff that is interesting, and then there's stuff that is useful, and you've got to find the overlap of those when you start to figure out how you're going to tackle data. And this will be the next webinar actually about how to get to quick wins, which is really just about planning. How do you plan out those sprints so that you can get to something useful? Well, it actually starts with, what do you need to know? The strategic knowledge has to be clear, and the information has to only show, evidence to that decision. It can't just be interesting for the sake of being interesting. And then the fifth is clear visuals. Humans are visual creatures. We process a visual image 60,000 times faster than a text. So the emphasis on data visualization is something that needs to be worked into a good culture. You as leaders need that basic understanding, and I'm going to get to the re-education component of this, but if you, even as decision makers, managers, or even someone who wants to start using data yourself, if you can't sit down and look at a data point and say, okay, where did it come from? Did it come from a survey? Was it an observational thing that was captured by a machine? Was it an experiment that we set up and ran? If you can't look at it and say, is this all data? Is this a sample, or is this all data on everybody? Right? You might have 30 customers, and you might talk to all 30 customers. That's census data. That's not sample data. You might have 1 million products, and you might only want to stress test a few of them because you can't sell all of them if you stress test them, in which case you're going to use a sample. You should understand the difference between those. Third is scope, is this time series data or cross-sectional data. That's a little bit more complicated, but stuff we will get into in the upcoming lectures. Measurement and freshness. Measurement is one that takes a whole lecture to outline this with people, to look at data and say, oh, that's nominal data or that's interval data. And the reason that's so important is because that determines what kind of analytics can actually be run. And so if you're a decision maker or a manager and someone comes into you and they say, oh, I ran the average on this, and then you look at the data and you say, this is nominal data. You can't run an average. It's nonsensical. All that happened is your categorical labels of 1, 2, 3, 4, 5 gave you a nonsensical value. You should be able to tell the difference, what type of data. And then the freshness, how useful is it and for how long? Data doesn't have to be big to be useful. I think this is another one of those things that limits people. They believe that if it's not perfect, then it's not worth doing, and that's really not the case. Small data can have a huge impact, and I've told the story before, and I'll tell it again right now, that one of the most impactful things I've ever actually seen in all of the projects, data science projects I've ever worked on, was one single histogram of what everybody thought was a trivial data point, which was logins through their web app. And it was just one of those throwaway metrics that someone said that they thought it'd be interesting. They really weren't sure what it'd be tied to with any strategy. We looked at it and it showed a very, very unexpected pattern, which is that nobody was logging in during the day. In fact, logins were peaking at 1 in the morning. And we went through all the roles. We went back to the data guardian, made sure that the data had been pulled correctly. We looked at the analytics that the analyst had, the data wrangler had done. We said, this is a good visual, it's correct. And we went to the organization, we said, we can't understand this, it doesn't make sense. We expected that this would peak in the day. Maybe you're batch dumping them at night and it's messing up the timestamps. And as we were meeting in this room, the data silos started to break down because the social media team said, hey, you know what? We've noticed that we get all of our complaints at night. And people are saying they can't log in, or they have some problem, or they have some question, and we just have an auto reply that says, we're sorry, we're not open. Call back tomorrow at 9 a.m. when nobody needs them. And then there was an actual Android and iOS app. So that app team said, hey, we've noticed that all of our logins are happening at the night too. And then one of the teams that managed internal processes and had access to this observational process data said, you know what? All of the processes that we see are taking off overnight. Everyone stepped back. We did some qualitative, small-scale research on their users, and what we found is that the main group that was using them were these independent sole proprietor contractors, and the company just didn't understand that person's daily flow because they were working during the day. They were doing their profession. They were HVAC people, bug people, direct sellers, eBay people. They were doing their daily work during normal office hours, and then they would get to their book work and their other administrative stuff in the evenings, which is when they needed this access to this program, and they just had a giant disconnect between what they understood with their customer. It was a tiny, tiny data point that started that entire thing. The other thing that you should understand as a decision maker and manager is that data is not infallible. It does not prove anything, it just provides a certain level of evidence. Anyone who says that they have proven something with data fundamentally misunderstands what's possible with data. The only way that you can avoid the issue of making the wrong decision on wrong data is replication. But every time I've ever heard someone say, you know, we got this one data point, it didn't make sense, and we went ahead with it anyways, but man, my gut was telling me not to do it. Intuition has a role. You as humans are still better than machines at processing and synthesizing information. That's going to change, but for right now, that human intuition is still very, very useful. And as long as you're politely skeptical and you're just asking for the right questions, and you can replicate things through iterative testing, then you don't have to take data as a blind truth, which some people do. I already talked about the combination of human and machine automation. You should, at this point, if you're about to build something new, you're actually in a very, very unique and rare position because everybody else that's trying to do this has to migrate existing systems or has to change people's protocols or has to tell somebody that the way that they've been doing their job processing Excel sheets for the last 20 years isn't going to be correct anymore and is going to be changed. That's a much harder thing to do. It's harder to move that culture than it is to create one from the beginning. And if you are in that situation where you're creating it from the beginning, you need to have someone who is at all times concerned with the idea of automation. Even programmers, if you tell programmers ahead of time, if you get a couple of these wranglers and you say ahead of time, I'm very interested in what code you can automate your own processes with. If you just empower them to do that, they have the skill set. There's been a couple of these urban legends among programmers floating around for a while of engineers who have automated their jobs and not told their employers. That skill set is absolutely within these people, and you should take advantage of it. Instead of discouraging it, you should encourage it and make it transparent because it will make it so you don't have to hire a second team. The other reason that if you're building this now, you're in a really competitive position is because one of the reasons these older organizations die, it's called creative destruction, right? Technological innovation destroys them. All these products in this image they're not sellable except for on eBay as a collector item. People are not going to go out and actually buy those 20 devices and carry them around. Instead, they want to buy the one device that does all of it, and that one device destroyed the market for those. Creative destruction is a constant companion in a market economy. It's just always there. Competition can always find a better way. And so because of that, you have to be building systems that respond. And things that were built 20, 30 years ago are locked in. It's called technological lock-in. The QWERTY keyboard is a good example of this, right? The keyboard that you're looking at, if you're joining this webinar on your machine that's right in front of you, is the byproduct of physical limitations of the early typewriter design. It has nothing to do with optimizing typing speed. And yet we're locked in because moving to that other way of typing would just be too hard, right? But brain computer interfaces are going to make it so you don't have to type, and then that technology will be creatively destroyed. So knowing this, as you're creating it, think about adaptability. Adaptability. Yeah, I think I'm saying that right. You need to be able to respond. You cannot create a one and done system and just hope that it's going to carry you for the rest of your tenure at that organization, or the lifetime of the product, or the lifetime of the corporation. Or you will very quickly be locked into antiquated technology. This stuff is changing so rapidly right now. I think a mandatory part of creating a data culture at any of these organizations is re-education. I think it's not enough for you to go hire these 4 data personas, give them a great environment, encourage them to automate, provide a lot of transparency, and just hope it's going to work, because they will be 5 individuals against the whole organization. If the whole organization doesn't re-educate itself, and it is re-education because, like I said, statistics was not taught well historically, is not currently taught very well. And so whatever it is that people do know about data right now, it's probably pretty limited, pretty out of date, and will cause a lot of conflict with these data scientists that you hire. So there has to be a component of re-education across the whole organization. Well, how do you do that? That's not an easy thing. There's a lot of solutions out there that you can go look at. I'm not going to tell you which solution to adopt. If you have questions, I am happy to talk about this. You can get my contact information from the site, or you can just get it after this conference. I'm happy to talk about any of them individually with you, but I still think that whatever it is you adopt, you're going to have to go through this 3-step process. The first is you're going to have to create a new baseline with your company, and the way I would do it is not to try to get everybody right away. For an organization that's probably in that 100 to 200 employee range, 20%, if you could get that, you'd be lucky. More than likely, you probably get about 10% who initially will attend something. I encourage you to use food as the bait. Lunch and learns are a great way. It's time that people already are supposed to take off, even if they're eating at their desk. It's an excuse to go eat at another desk and to learn something in the process. It's not hard to realign the baseline in your organization. Use food, bring people in voluntarily, get them excited, get them empowered, and then they will be the leaders that push this to the rest of the organization. And if this is a continued and ongoing thing and people are seeing that other people had a good time, this is how seminars and things like this build momentum. Once that is going, the next step is deep dive. There are people in your organization who are not data scientists, but who have good ideas about what they could do if they just knew the answer to something. And if you can find them through the lunch and learns, they'll usually be the ones who hang around at the end and ask some questions. You're going to get a much smaller group. This is like any funnel, right? You're going to have some people who attend at the beginning at the lunch and learns, and then you're going to have a smaller group that comes into the deep dives. The 3-part seminar with a smaller group of people where they can start to get really deep data support will empower them to bring the data science teams into their departments. And then the third is that once that education is happening, the decision makers and stakeholders have to get on the same page about what it means to have data protocols, a central environment, and broad access. If you are successful in creating that data environment, that data culture, right? So a centralized environment, a re-educated core team, another level of specialization for people who need it, and you've got this functioning data science team, you will see very, very quick progress, right? And these quick wins will be what actually sustains the momentum to keep going. So right now, the way that people get to the quick wins is they just guess, rapid guessing. And rapid guessing is great. I like the rapid part. The guessing part could be improved with just a little bit more information. Again, it's not as though the data is definitive. It's just that it's additional information to consider before making those rapid decisions. Quick wins, things that are easy to get at. You know, you've had the lunch and learn. Some people hung around. Your data science team sees, oh, this person from marketing has this very specific question, and they do something within a 2-week, 4-week, or 6-week sprint, and it has measurable, demonstrable success. That will spread quickly through the rest of the company. Other people will want access to that help, and this will be what gets you away from the scientific wild ask guess approach. This is also the purpose of the next lecture that's coming up. The next in-person lecture is on August 18th. The next webinar repeat of that lecture will be on August 22nd. You can find information about both of these things on our website, emperitas.com/lecture, or for the webinar, it's just /webinar. If you have questions, I believe we've got a couple minutes left. I will stick around. Otherwise, thank you for joining me today, and I hope to see you at the next one.